So, did any of you read this one? Oh, sorry, this one. Okay. So we talked about last time that you used to, for Node.js, you're used to just using a JSON file to store stuff on the disk, right? And it's, that works for small prototypes and stuff like that. And one of the main reasons for using databases in production systems is these, we call them the asset properties or asset model, whatever you call it, is that it's basically, it sounds very fancy, but it's very, very simple. So atomicity means that either something happens or doesn't. So if you say to the database, please insert a row into this table, and then you get a response back that says, one row inserted, then you can 100% be guaranteed that has happened. So let's say you get that response back, and then everything crashes and all the power goes out, and when you turn it back on, that thing will still be there. So if you have some system that has millions of queries per second, then data will still be there when you power it back up again. As long as you know that you have a response that says it happened. So, and you can do this both on single query level, where you say insert into some table something, or you can use what's called a transaction. We haven't talked about that yet, but transactions are basically, you can execute multiple queries as one step. So let's say you wanted to insert a user, and you also wanted to insert some task for the user, whatever, an example task, right? In this case for the task table. And you want to do that as one. So then you say transaction start, insert a user, insert a task, transaction commit, and then they both either happen or they don't. You can't have one of them happen, the other not. So it's like everything happens or it doesn't. So it's atomic, that's the smallest level of, of action. And consistency means that you cannot break the rules. So for this task and the user table and the other tables, in the user table, for example, it says that the user has to have a name. So you cannot break the rules and insert a user with no name. So you cannot not define a name. You're going to get an error back. So you can be sure that the data you have in the database follows the rules. And that when you try to write something to the database that breaks the rules, it's not going to work.
It's the same thing for relationships. So in the example database, a task has to have a status, but the user can be null. So if it's not nullable, then you have to put in a valid status ID.
Yeah, we can try it actually. Let's try it. Let me say. No, I can't remember how many things are in the task. Let me just. Yes, that's correct. Okay. So databases, use. I just gotta remember what's there. ID, title, description. Okay, let's say insert into task values. This is how you insert data. We haven't talked about it. Let's say just task description, blah blah. Just say this is the timestamp for when it was created and updated. So we just say now, which is just the current time. Due date now as well. It's a very short-lived task. Status ID, that should be 1. Now let's say 5, and then user is 1, right? So now we're going to try to insert a task into a task table with no ID because that's auto-generated. Title of test task, description of blah blah, some timestamps, and then a status ID of 5 and a user ID of 1. And this is probably going to fail because there's no status with the ID 5. So it says cannot. Yeah, I can't see that.
Cannot add or update child row.
A foreign key constraint fails because we define the table as being, as Fleming said, the status ID has to point to an ID that exists in the status table. So you can't break the rules. And then, depending on what rules you set up when you created the table, let's say there was a status with ID 5, and then we deleted that status, then that would fail. You cannot delete it because there are other tasks pointing to that status. So it also works the other way around. Back here. Yeah. Perfect. And isolation means that the queries that run don't impact each other's execution. So the best example is, I guess that's a race condition. That's not really. So when you're committing queries, then they happen one after the other. One will always happen before the other. So if you make a query and you make a query and you make a query and I make a query at the same time, then the database will order them somehow, and then yours will execute yours, and then mine. So they will happen in isolation and they cannot impact each other. So if you have a bank database and you say you want to subtract 50 kroner from your account, and then he does it and he does it and I do it, then 50 kroner is subtracted every time, and I use the amount of money that was in after you subtracted it, and so on. It happens in isolation, and it would be. It doesn't guarantee which one happens first. It just guarantees that they will happen in isolation, so you don't have conflicts, basically. And the last one, durability, is that stuff that is, I think that kind of links with the first one as well. Stuff that has been committed to the database does not get lost. So, for example, I know with MySQL that we're using, if 1 millisecond after you commit something to the database, you unplug the power cord, then it's still there. Next time you boot it up, it might need a minute or two to recover and generate everything, but it's there, and that's also one of the reasons why they're maybe not as fast as other database types and stuff like that. But it means that you keep your data. You can also, for example, I know for MySQL you can tweak it to say that, okay, it's okay that I lose the last X amount of megabyte of queries if I crash, and then it's a lot faster. But then you have to risk losing stuff. And if you have a Twitter or whatever, that's probably not a big problem. But if you have a bank, then you don't want to lose anything because the database crashed. So yeah. I think we're going to use this a bit later, but this is just how to connect to MySQL on from Node that you used to. And it's very simple. We have an example here. There it is, Node MySQL connection. So this is basically how you connect. We're going to use that a bit later. You connect, create connection, then you can start querying it like the queries we showed before. And that's it. And you can use the data in Node. Yeah. So you saw a little bit of the insert into. This is basically what I had. Where'd it go? Here we go. So inserting into a database is as simple as this. You just select the table you want to insert into, and then you list the values, and that's basically it. You can insert into any table that you have the rights to insert stuff into, the permissions to insert stuff into. And on your computers, you're the administrative user, so you can insert into anything. And you can do. Let's find the manual here. No, that's not the manual. There we go. Yeah, this wasn't the manual, but this is another example. Let's try this. So basically, so you notice this one at the top, I didn't specify which columns I insert data into. So if you don't do that, you just take the columns as they are defined in the database. As we can see here, if you describe the table, you get the fields in this order. So if you don't specify the order, then you just insert in that order. So for example, if I wanted to avoid writing null here, I could just do I could just do, let's remove the null, and then say what was it, title?
Title and description, created.
Actually, description can be null, so let's remove that as well. Title, 2, 3, 4, and then it's user. Which one comes first? Status ID, and then user ID. Just delete this stuff down here.
You can see when you look at the description of the table.
What am I missing?
Can we switch to the terminal again?
Yeah.
You can see under the column null, it says no or yes, depending on.
Yeah. So for example, here the description field can be null, can be empty.
So it's an optional.
Yeah.
Okay.
And due date as well, and user as well.
Okay.
What am I missing here? Let's try it. Okay, yeah, it works fine. So now if I say select, do that here, maybe select. Yeah, it's a bit hard to see, but here it is, test task. And that's basically how you insert into any table. It's a good idea to use the describe method if you don't know what a table looks like. Then you can start inserting stuff, and you get everything you need to know to insert stuff into the database. So I know here that this field could be null, so I just have to provide a name and an email. You could provide the ID as well, but since it is auto generated, then there's no reason to, because the database does it for you. So there's no reason to do it. And you can see what keys are the primary keys. So let's get back to the material. Update looks a lot like insert. So let's say we have, we can do this here because the queries are a bit smaller, so it's a bit easier to see here without so much. So let's, I wrote it wrong. There we go. Okay, that was maybe a bit too big. So we have the ID, name, and email and phone, right? So let's say we select. So we want to change the phone number of Anton here. And we say update user set phone equal whatever something. So there is one danger with this is if I press enter now, if I put a semicolon press enter now, then all phone numbers in that table are going to be changed to 09 whatever. So it's a really good idea. So here I would do ID equals 13, right? Now he has a new phone number. So when you're updating stuff, which is also we'll get to with delete, it's usually a good idea to write a select query first and say select star from user where ID equals 13. Let's see. Okay, this is the user I want to do something with, and then I can change this to update user set phone equals something. So yeah, it's good to remember that there's no limit on what's going to happen if you don't have the where. You could actually, as far as I remember, you can put a limit on an update query, can't you?
I think so, yeah.
We can try it. Let's see. Let's see. Okay, now we have all the users. We want to update. So let's say we did a. We have the correct one here. That works. I think we can do this. Yeah. So let's say if we forgot this thing, and we put limit 1 in. Let's see.
And at least the damage is not
Yeah.
that bad. It's
Yeah.
only
We only fucked up the first user. But it's good if you know that you're only going to delete or update one thing. For example, if you're deleting something that's unique in the table, like a user account or something like that, or you're deleting one task or something, you might as well put a limit in just to, because you know that it's only going to be one, so there's no reason to tempt fate and not have it in. Might as
After
well.
updation is we cannot recover this phone number.
No.
Oh.
No, now the phone number is gone.
It's written out. It's overwritten in the database.
Yeah, it's overwritten on the disk. Yeah, and it's it might still be there somewhere on the disk, but I don't think there's any easy way to recover it. So it's also good to have backups of everything. Backups. Otherwise,
So with database, there is no undo.
no,
Oh.
no, there's
Not built in.
No.
But there's some people who do their own kind of undo system in the database. So instead of they never update anything, they also always insert.
Yeah.
So you can rebuild the whole history, but that's a bit advanced.
Yeah. It's just let's say instead of updating this Arika's phone number, you just insert a new row. We have another column that says version or something. Then we insert a new row with her account details, and then we set that version to the highest one. So then you have previous version of the Arika user has another phone number, the newest version has this phone number. Then you can go back in history, but that means that you store everything that ever happened in your database. It's
a trade-off.
Yeah.
So
it is. It's you have a lot more data to look through, but you don't have any issues with people. You can always go back and see what happened before if you want that. But I don't think I've ever used it yet. I've always used it with backups, and I've used it with like addresses. So if you have a user table, for example, right, and they're switching addresses, so they're going from one address to the next. It's still nice to see what their former address was. If we want to see, okay, well, we shipped some products to that user and they changed their address. So what was the previous address we sent to? So then you have a separate table that is user underscore addresses or something like that. And then you could have address version 1 to Isaac is whatever street something, and then you insert a new address that is now the current address, but we still store the old one. Just so we can, we have a history of where you sent products to, where we have sent products to. Delete looks a lot like update. So we do, as I said before, it's good to, let's say we want to ID, title from task. We want to delete the test task because we don't need that anymore. So then we do the select first, and then we do delete. So there, 37. And now I'm going to run it again. It's not going to happen because there's nothing to delete. And I can still add the limit here if I want to. And that's basically, that's the same. With tables where you have what do you call it? Relationships. So here, for example, in the task table, you have the status ID and you have the user ID. So let's say I wanted to delete something I wanted to delete a user that has tasks. Then depending on how the database is set up, then either it will fail and say you cannot delete this user because they have tasks assigned to them, and then you would need to go in and either unassign those tasks or assign them to someone else, or delete them and then delete the user. But there's also, when you create a table, there's something called cascading changes, which means, or cascading properties, whatever we call them, means that if you delete the user and there are any task items that point to that user, they will be deleted as well. So
you can set up different rules depending on what you need. You can also say if the user is deleted, then set all the user's tasks to null instead.
I can't remember.
Deleted, then maybe automatically goes to a user who is free.
Yeah, you can do that. You can do. You can say set null, which means just unassign it whenever someone. We can probably look at here what it says. So let's see if we can find it here. Task. Yeah. So we've set it to user ID on delete cascade, which means that when the user is deleted, the tasks that are assigned to them will disappear as well. So we can try that. Let's select all the users. So let's get this Anton guy. So does he have any tasks? Select title from task where user ID equals 13. Well, he doesn't have any. let's insert something to him then, just to be nice to him. And let's say, let's give him a test task. So now he should have a task. Yeah. Let's try and delete this user from user where ID 13. So now the user is going to be deleted and his task is going to be deleted. So the task with ID 38 is disappeared. It's not there anymore. And that's because we had the onDelete cascade when we created the table. Let's get back to the content. Yeah, connecting to MySQL from Node.js is really simple. I'll show you how. I think it's in here, right? Yeah. So the only thing you have to do is edit this file called, I can list it here, config secrets.json to contain the credentials for your own local database. So in my case, it's root, the password is HYF, and database is HYF1. That's it. And you have to do the npm install and stuff as well, I think, right? If it's not already. Yeah. So then we have this index.js file. It's going to connect to the database. It's going to make a query, and then it's going to spit out the results to us. So let's try it. Yeah. So you see it, row something, Donald Duck, Elias something, some Chinese name. So it's just, yeah, that's how you connect to it from Node.js. It's really you're using this module called MySQL. And, there we go. This MySQL module that does everything for you. So there's no reason to use anything but that. Yeah, let's pause for a second and have you try and connect to your own MySQL databases with Node, just to make sure that it works, and then we can continue with the security stuff.